Welcome to Earth Science, everybody. So, yesterday's lesson, or earlier today, depending on what period you're doing all of this, we tried to talk about this redshift deal. So, let's review because, again, these questions aren't terribly like in depth or difficult. It's more like recognizing. But if we can just get these two things down, they'll repeat those questions over and over again. When you see the classwork I do with this, you're going to feel like it's the same question over and over again 10 times. So, let's do it. If the stars are moving, as we observe, away from us, a wavelength of light. Remember, what happens as something's moving away? What happens to wavelength? What do you think? Wavelength increases. That is Doppler effect. That's Doppler shift. And again, it works with that duck in the water. It works with sound. Listen to a car drive by, and it works with light. Though that's a lot harder to observe because it takes like ridiculous speed and very large distances with these stars to recognize that. But as a result, the color of the stars go through this thing called redshift. And remember, I had you circle it. I promised that it would be the most important thing. That redshift shows us that we have an expanding universe. Let's circle it again because, hey, I can't say enough about how, again, all of this, if I talk for a half an hour on these videos, it really comes down to what's right here. We'll look at it in a minute. Redshift and cosmic background radiation. So, cosmic background radiation, what is it? That's what today's little quick job is going to be. Cosmic background radiation is further evidence of the Big Bang Theory. So the idea was there was these theories out there that we had an expanding universe and therefore it had to be like from a single origin, and that was the origin of the Big Bang Theory, but it wasn't necessarily accepted by everybody. And it's one of those things that, like, yeah, this is how science works. People have ideas, you gather evidence, you look for more, and eventually this little discovery would be the thing that would really like lock Big Bang Theory into being widely accepted across experts in the field across the board for years now, decades now. So, in an effort to both say, I don't want to pull your chain and say that there's all this history of it you got to know, but I don't want to ignore it either. So, you got two paths. You can shortcut and just say, okay, Mr. F is telling me that I got to know, and you do. This is the no nonsense part. You got to know that cosmic background radiation is one of the things that shows us that we live in a Big Bang universe. The questions, the very repetitive questions are, what evidence do we have for the Big Bang? And it's those two things. And this is right from the state standards. When I show you these things, remember that they're the standards. And the questions don't really tend to go in depth. So if you want to say, okay, cosmic background radiation, Big Bang, I'll lock those two upstairs. We're good. The history of it, I think, is kind of neat, but I'm not going to pretend that you're going to be tested on it because you won't. So, in an effort not to force you through too many hoops. Let's check it out real quick. See what you think. Penzias and Wilson, these two fellows right here, you guess, detected a signal that they could not immediately explain. It was basically like a noise, like a background noise using this huge horn antenna for communications. This thing, like you can see that right there, the whole thing spins like one of those, like a record, basically, right? One of those things at the elementary park playground. So that can spin around in all directions, and then you see that big wheel right there. That whole thing can turn. This thing can basically point in all directions. They were doing communication experiments, but no matter what, they picked up this noise that they couldn't explain, couldn't figure it out. Um, they thought maybe it was like New York. This is in New Jersey. New York City's nearby, so they pointed it over there, pointed it away to try to like compare that noise from what they might pick up somewhere else. Didn't show them anything. There was pigeons living in there. They chased them all out, but the pigeons came back and they shot them. Actually, cleaned out all the bird poop. Thought maybe that like we just had some interference from that. Nothing. It was still there no matter what they did. So turns out there was other people actually saying, you know what? If there was a Big Bang and it happened at about this point, there should still be this like this essentially this is simplifying, but essentially this energy that's kind of still banging around the universe. We should be able to pick that up. As it turns out, these two dudes working in communications were picking that up and thinking it was bird poop, right? So once everybody kind of got their heads together, they realized that this noise they were detecting was the Big Bang, in a sense. If you ever, these are old TVs, right? Digital TVs don't do this anymore. But if you've ever seen a TV do this, like this static, part of that, a very small part, but part of it is cosmic background radiation, which is what's left over from the Big Bang, that energy that still reverberates around the universe, that's cooled and slowed down since it happened. So, in a weird sense, certainly not a very literal sense, but in a weird sense, you're watching the Big Bang on TV if you've got static on there. Okay. Again, short story. You want to do that? Cosmic background radiation, Big Bang. Boom, boom. Those two, and you're good. Okay. This stuff that's on this state standard right here is the thing. The universe is vast and estimated to be over 10 billion years old. It's really around 14. The current theory is that the universe was created from an explosion. Not a fantastic word, but we'll cut New York some slack. Called the Big Bang. Evidence for this theory includes, and again, those two bullets, they're going to ask it, get it down today, get it down tomorrow. It will be on the quizzes and tests, no doubt, and it will probably be one of the first questions you see on the Regents within the first 5. So to wrap up all this noise, thanks for sticking with me, folks. I know these videos can be long. About 14 billion years ago, the Big Bang occurred. From this, all matter in the universe has been expanding ever since. We don't really have to get too nitty gritty on this. It's interesting, it's cool, but it can be pretty difficult at times too. Getting into like how subatomic particles formed and then atoms formed, but it really would have been a very at the very beginning would have been really just like hydrogen, would have been just the simplest and smallest of elements. We talked about already how in stars, two hydrogens, the latest element we have, combine into helium. This is what's going on in our sun, combine into helium through a process we call fusion, and that releases energy, a lot of energy. That has happened, and stars have formed and died, and formed and died, and formed and died. And whenever that happens, smaller atoms are going through fusion and turning into bigger atoms. Because at the end of the day, if we started with a Big Bang that was really mostly very early in it, hydrogen, that's all you really had at the very beginning. How do we get to a pair of sunglasses? How do we get to things that are made of other stuff? How do we get to the carbon that's in my all of our bodies? And it's by stars forming and dying and forming and dying and forming and dying. So all of that, the stuff that's in you right now, was formed in one of these stars that formed, died, spread out its guts, and eventually would form a nebula that then would come together into another solar system and another star. So yeah, I mean, wild. From this, all matter in the universe has been expanding ever since. Eventually, some bits of this matter would develop a bunch of stuff. I don't remember what I said here last year, but stars, planets. Oh, I was going to say I was going to write you and I, but along with that, you and I mean, larger molecules, larger atoms, everything really, up to us. So with all of like the just mind blowing openness and like questions that may raise, things we can go a little deeper on. If we're going to do a bare bones, what do I need to get through this Regents? What do I need to get through this astronomy test? It's that. Oop, it's that. Universe is expanding. We know this because of observing redshift, which is that Doppler shift. Cosmic background radiation really locked up Big Bang Theory and let us know that was the case. Or, like the state standards say, that. So, I said in the last note sheet that those 4 questions will be part of a classwork. I took the rest off of this one. I'll just make one document with all the questions, and I'll repeat those 4. So if you did them, you're still going to be able to use those answers. And you'll see that these questions are fairly repetitive and fairly straightforward and fairly simple. Thanks so much for sticking with me. How long did I make you sit here? Oh, we're less than 10 minutes. No big deal. Thanks, folks. Catch you soon.